Hello everyone, I'm Dr. Manzoor Ahmed from the Department of H&S Mathematics, Marri Laxman Reddy Institute of Technology and Management. And today we are back with one more lecture of Vedic Mathematics, that is rapid cubes. Today we will learn about how we conduct the cubes of different numbers, or how we find the cubes of different numbers in mathematics using Vedic Mathematics techniques. Actually, as you all already know, that there are different methods and techniques to find the cube roots of numbers and the cubes of numbers. But the most important ones here are the Yavadunam Sutra and Nikhilam Sutra. These are the two most important methods as per our curriculum. Even though only one of the methods is discussed as per our curriculum, Yavadunam Sutra. But we will go through both of them as they are equally important to find the cubes of numbers. So here is, if we have to find the cube of any number using this Yavadunam Sutra, which is greater than the base, so the formula is given as g plus 2 into d backslash 3d square slash d cube. Now here g, what is g? G is the given number to which we have to find the cube root or the cube. D is the deviation of the given number from its nearest base, and here this is the formula for calculating the cube of any number. Now, how do we use and in what situations do we use Yavadunam Sutra, or what is the need for using Nikhilam Sutra? Here you can find that Yavadunam Sutra is used to find the cubes of numbers that lie close to the base 10 to the power n. So I will make it a little clear. 10 to the power n means which are close to the base 10, or which are close to the base 100, or which are close to the base 10,000 and 10,000, so on and so forth. So for those numbers which lie close to these numbers 10, 100,000, 10,000, 1 lakh, so on and so forth, we use Yavadunam Sutra, or Yavadunam Sutra is the easiest method to find the cubes of those numbers. So here is the first example. If we have to find the cube root or the cube of 12, which is close to the base 10, so how can we use Yavadunam Sutra to find the cube of this number, which is 12? So 12 is the given number, and as per Yavadunam Sutra formula, we have to calculate the cube of 12. So the formula is given as g plus 2 into d slash 3d square slash d cube, where you all know g is the given number, which is 12 in this case. D is the deviation from its base. So students, you all know that the base is 10 because 12 lies close to the base 10, and the deviation is 12 minus 10, that is 12 is 2 places greater than the base 2. So to find the cube of 12, it goes as per formula 12, which is g plus 2 by formula into d. D is the deviation, which is again 2 in this case, slash 3d square. D square is again deviation square slash d cube. When we put the values in this, we get 12 plus 2 into 2, 3 into 2 square, 2 cube. Here we find 12 plus 4, 3 into 4 and 8. Now you see the most important point here. When we find the cube of 12, we get 16 slash 12 slash 8. Now here one thing is to be mentioned, which is very important. So after first separator, if you can see, there is a 2-digit number, and after that there is a single digit number here. But as per this Yavadunam Sutra, if we find the base, that is 10, here you can see the base is 10, so there is only 1 0 in this base. So after the first separator, the numbers should be a single digit number. So that means this 1 will go here to the left, and it will get added to this 16. So students, you can take this 1 here to the left of the number. That becomes 16 plus 1, that is 17. Here we are left with a single digit number now, 2, and then we have again a single digit number, 8. So when we combine these numbers, we get 12 cube equals to 1728. So this way we can find the cube of any number using this sutra, which is popularly known as Yavadunam Sutra. Let's move to one more example and we find the cube of other numbers using this sutra. So in the previous example, we had taken a 2-digit number, and in this example, we are taking a 3-digit number, that is 104. And when we have to find the cube of 104, so using Yavadunam Sutra, we first use this formula for calculating the cube, and we know that 104 lies close to the base 100, and here the deviation is 104 minus 100, that is 4. The deviation in this case is 4. The given number in this case is 104. So as per the previous example, you can see that to find the cube of 104, we have to go like this: 104, which is the given number, plus 2 into deviation backslash 3d square slash d cube. D here is nothing but the deviation of the given number from its base. So here the number is 104. So when we have to find the deviation of the number from its base, we have to just subtract that base from the given number, so we can find the deviation, which is 4. Now you put the values here: 104 plus 2 into deviation equals to 4, and slash 3 into 4 square slash 4 cube. So we get the values as 104 plus 2 into 4 is 8, and 4 square into 3 is 48, and then we have 4 cube, that is 64. Now again the same thing is here. We see 104 cube equals to 112 slash 48 slash 64. Now here, students, look clearly. Here in the base we have 2 zeros. In the previous example we had only 1 zero in the base. That is why after the first separator, if there were more than 2 digits, or if there are more than numbers having more than 2 digits, we have to move the digit we have to make it a single digit number and move the other digits to the left. But here there is no problem, as you can see clearly that 48 is a 2-digit number and 64 is again a 2-digit number. And if we see the base, which is 100 in this case, that is having 2 zeros, so there is no problem in moving or the numbers to the left or right. So we can go with this formula and we can use, we have nothing to move here. We have 2-digit numbers and 2 zeros in the base, so there is no point of moving these digits to the left. So we can go 104 cube equals to 112 slash 42 slash 64, which is, after combining them and removing the separators, we can see the cube of 104 is 1124864. So this is one more example where we have find the cube of any number using Yavadunam Sutra. We have taken one more example and we are here to find the cube of this number, which is a 2-digit number. Very easy. We have to find the cube of 18. So by the previous formula we can use this formula, and here you can see that the deviation is 8, because 18, when we see, students, it lies close to the base 10. So when we subtract the base from the given number, the deviation is 8. Now to find the cube of 18, we use the formula that is given above here. So put these values and replace the given values. We see 18 cube equals to 18 plus 8 into 2 is 16, where 8 is the deviation, slash 3 into 8 square, which is 64, and 8 cube, which is 512. Now when you see here 18 cube equals to 34 slash 192, then we have a 3-digit number 512. Now here we need to understand that as the base has a single zero, you can see the base is 10, so it is having a single zero, but to the right of the separator we have 3-digit numbers. So to make them single digit numbers, we need to move the numbers to the left. So we will start from here. Here 512 is a 3-digit number. That means we have to add this 5 to this 9 and this 1 to this 2, which becomes, after adding 51 to 192, this becomes 243, and here we are left with a single digit number 2. Again, here we have a 3-digit number, here we have a 1-digit number. So to make this a single digit number, we have to add this 2 to this 3 and 4 to 4, which becomes 3 plus 2 is 5, 4 plus 4 is 8. Then we are left with a single digit number here, 3 4. When 2 4 is added to it, here we are left with a single digit number 3, and here we have 2. That means 3 plus 2 is 5, 4 plus 4 is 8, and this is a single digit number, and again we have a single digit number. When we combine these numbers, this becomes 5 8 3 2. So this is a very important point that students should remember here, that when we have a base which is having a single zero, in that case we should note that after the first separator, the numbers should be single digit numbers. Now if we are having a base which is having 2 zeros, then that means to the right of the first separator we should have numbers that should have 2 digits. If we have more than 2 digits, then we need to move the other digits to the left of the number and add it to the number. So this way, again, if you find that if we have to find the cube of 18, that is simply by using this formula for Yavadhanam Sutra, and then accordingly we have to adjust these numbers. This is one more important point. And if there is a single zero in the base, that means after this separator there should be single digit numbers, and the rest of the, if they are occurring more than 2 single digit numbers, for example 2 digit numbers, 3 digit numbers, then we have to move those numbers to the left and add to the number, and by this way we can find the cube of numbers. This is all about Yavadhanam Sutra. You can use this sutra to find the cube of other numbers or any number in Vedic mathematics. Now we have one more important sutra, that is Nikhilam Sutra. Now here the question is, if we have Yavadhanam Sutra to find the cubes of numbers, then why is there the need to find the cubes of numbers using Nikhilam Sutra? You see, we have already discussed in our previous lectures that for most of the numbers which lie close to the base 10 to the power n, that means here we have numbers like 10, 100, 1000, 10,000, and so on and so forth. For these numbers, for the numbers that lie close to these bases, we can use Yavadhanam Sutra to find the cubes. Now, if a number is, for example, 45, so students may get confused here. So whether it lies close to the base 10 or it lies close to the base 100. So for numbers like these, we have Nikhilam Sutra, where we have to find the sub base. Then we make use of that sub base and find the cube of these numbers. Once we are going to the examples, you will clearly understand why do we use Nikhilam Sutra and why do we use Yavadhanam Sutra. Even though this Nikhilam Sutra can be used to find the cube of any number, but Yavadhanam Sutra is most preferred when it comes to find the cubes of numbers that lie close to the bases 10, 100, 1000, 10,000, 1 lakh, so on and so forth. So here this Nikhilam Sutra, as we know, is used to find the cubes of numbers which don't lie close to the base 10 to the power n, but rather they are a multiple of 10. So let's move to the example and we will try to understand this Nikhilam Sutra through an example. For example, we have to find the cube of a number 45. So I have already discussed about that. If you have to find the cube of the number 45, where students may get confused whether this number lies close to the base 100 or this lies close to the base 10. So to remove that ambiguity or to remove that confusion, we simply prefer using Nikhilam Sutra over Yavadhanam Sutra. So how to use Nikhilam Sutra? The formula for that is G plus 2D into SB square slash 3D square into SB slash D cube, where G is the given number, as you all know. D stands for deviation, and here we have a new term, that is SB. SB is nothing but sub base, and we will here understand what a sub base means and how we can calculate it, the value of sub base. So you can clearly see here G is the given number, D is the deviation from its base, and SB is the sub base. Now students, you see here we have the number 45, and as per Nikhilam Sutra, if we have to find the cube of this number, we need to first find the sub base, or we can say the working base. To find the cube of this number 45, this number lies close to which working base, we need to find it first. So 45, you always know that 45 lies close to the working base 40. Now here you see 40 is a multiple of 10, 4 into 10. So 40 can be put here. We have clearly mentioned it over here that 40 is equal to 4 into 10. Now what is meant by 40? 40 can be regarded as a working base, where 4 can be taken as a sub base, and 10, this 10 works as the actual base. So in questions like this, we have actually taken into consideration three things, that when we have to find the cube of any number that lies close to any working base, we have to calculate first the working base, then it should be taken as a multiple of 10. In this case, the working base is 40. So 40 can be broken into 4 into 10, which means 4 is the sub base and 10 is the actual base. Now once we are able to find the working base, the actual base and the sub base, then the cube root of 45 is easy to calculate. Now you see, use this formula, 45 equals to given number plus 2 into 5, 2 into deviation. Now you see that deviation, we have to take the cube of 45. So 45 is how much place is greater than the working base? We have to take deviation 45 minus 40 equals to 5. So don't be confused about deviation and sub base. 45 is 5 places greater than the working base. That means 45 minus 40 equals to 5. So 5 is considered here to be the deviation, and 4 is considered to be the sub base, because the actual base, which is 40 in this case, that can be written as 4 into 10, where 4 is known as sub base and 10 is known as the actual base, and 40 is known as the working base. So I remember these terms. Now if you come here, 45 cube equals to, put these values, G is given number which is 45 plus 2 into deviation, deviation is 5 in this case, into 4 square, that is sub base square, 3 into 5 square, deviation square, into 4 sub base slash 5 cube. When we calculate these terms, we find 45 plus 5 into 10 is 45 plus 10 is 55 into 16 slash 75, 5 square into 3, 75 into 4 slash 125. Now here when we multiply 55 by 16, that is 880 slash, this is 75 into 4 is 300 slash 125. Again, what students need to remember here is we have only 1 0 in the actual base, which is 10 in this case. Now after the first separator, if you can see, we have numbers of 3, we have 3-digit numbers, so we need to reduce them to a single digit number by taking the other numbers to the left and add them. Now you see here we have a number like 880 slash 300 slash 125. Now as I have already told you that to the right of this separator, if we have more than a single digit number, we need to reduce it to a single digit number. So here we have a 3-digit number, here again we have a 3-digit number. So we will start with the right. This 1 and 2 will come here, 1 and 2, this becomes 880, 3, 0 plus 1 is 1, 0 plus 2 is 2. So here we have a single digit number. By taking these two numbers to the left and add them to the requisite number. Now again we have a 3-digit number here. Here the thing has been cleared and there is no problem with this one. Now the problem lies with this one. After the first separator, there should be only the single digit numbers, because the base contains here a single zero. So 880. So when we take this 3 to here and this 1 to here, here we are left with a single digit number, and then here we have again a single digit number. Now when we add these numbers, 1 plus 0 is 1, 8 plus 3 is 11, 1 is carried over to here, that becomes 9, this is 2, this is 5. So when we remove the separators and combine the numbers, this is 9, 1, 1, 2, 5, which is the cube of 45. So by using Nihilum Sutra, it is easy to find the cube of any number. And remember here, this Nihilum Sutra can be used to find the cube of any number, but we prefer using Yavadunam Sutra for those numbers which lie close to the base 10 to the power n. Otherwise, this method is applicable, and this method can be used to find the cube of any number. So I hope you have understand the use of Nihilum Sutra as well as Yavadunam Sutra. So let's move to one more example, and this will give us more insights about the use of Nihilum Sutra. So we have taken one more example where it is in the previous example we had taken a 2-digit number, but in this example we have considered a 3-digit number. So to find the cube of 162 using Nihilum Sutra, sorry, it is Nihilum here. So using Nihilum Sutra, we will use the formula and calculate the cube. So the formula is given as g plus 2d into sb square slash 3d square into sb slash d cube. As you already know now, g is the given number, d stands for the deviation of the number from its working base here, sb is the sub base, and then put these values. If we see 162 is close to the working base 160, if we see 162 is the number to which we have to calculate the cube. So 162 lies close to the working base 160, because 160 is a multiple of 10, or 16 into 10 is 160. So if you see here, 162 is 2 places greater than the working base. That means 2 is the deviation. So we are able to find here the deviation, which is 2. Here we have given it 162 minus 160 equals to 2. Now to calculate the cube of 162, we put the values, the given number, the deviation, the base, sub base value, and calculate the values. Now here when we see 166 plus 4 is 162 plus 4 is 166, and 16 square is 256 slash this is 12 and this is 16, then we have the cube of 2, that is 8. Now here, after calculating this multiplication, you can use Vedic techniques to calculate this multiplication as well, and to make things more easier. So we will not dive into the deeper details as we are running short of time. So you can use even Vedic techniques to calculate this multiplication over here. Now in this case, by multiplying 166 into 256, we are getting the number 42496. Then we have 12 into 16, 192 slash 8. Now see here, we have a single digit number, but when we move to the right and left of these separators, we have a 3-digit number. But as per the formula, as per Nihilum Sutra, we can have only a single digit number here and a single digit number here. But when we look at this number, it is a single digit number, so no problem with this. But we have to move this 1 and 9 to the left and add it to this given number. So when we move it, this is 9, this is 1. So when we add it to 42496, this becomes 42515. After adding 19 to 42,496, this becomes 42,515. Then we have a single digit number here and single digit number here. Now there is no problem with this. We can remove the separators and we can get the number as 4251528, which is the cube of 162. So how these methods work and what is the importance or the benefits of using these Vedic techniques, because it can reduce our computational work to a larger extent by saving our time and energy. You see, when once we are well versed with these methods, and once we know about these methods, it's very easy to calculate the cubes of numbers, to calculate the squares of numbers, as we have already seen in our previous lectures. So these are the methods that we can use to find the cube of any number using this sutra, Yavadunam Sutra and Nikhilam Sutra. But as per our curriculum, only Yavadunam Sutra is mentioned, but I found it equally important to use Nikhilam Sutra as well. So we have used both these methods, and we have taken some examples to calculate the cubes of certain numbers. Students can use these two sutras to calculate the cubes of any number which they want to calculate. So we will move on to the next part of the lecture, which is the last unit of our curriculum, which is contribution of Indian mathematicians to Vedic mathematics. You know, Varamihira was one of the oldest mathematicians from 505 to 587 CE. He was a major classical Indian scholar, but it is very important at this outset, he is not a direct contributor, but whatever he has done, that has become a baseline for Vedic mathematical techniques. Because Bharati Krishna Tirtha ji, when taken the scripts from different Vedas, particularly the Atharva Veda, those he made use of these techniques which were already given by mathematicians like Varamihira. So Varamihira is not a direct contributor to Vedic mathematics, but Bharati Krishna Tirtha ji has instead taken his contributions from his works, and he has majorly dedicated it to the development of Vedic mathematics. So why is Varamihira sometimes linked to Vedic mathematics? He wrote in Sanskrit. That is the important thing that we have. So because Vedic mathematics all given in Sanskrit, so whatever scripts or whatever writings Varamihira has already developed, that became a base for the development of Vedic mathematics. He worked in traditions that trace intellectual roots to the Vedas. As we all know that Vedic mathematics is mostly derived from Vedas, and Varamihira has already given some works to trace intellectual roots to the Vedas. His methods feel Vedic in style, that is mental computations, verbal rules. So whatever methods Varamihira has already declared or contributed, that look like more of Vedic style, such that we can have mental computations, verbal rules are given in those methods. And modern popular discourse often uses Vedic mathematics broadly and inaccurately. These are the contributions that Varamihira has given to Vedic mathematics. Now, another Indian mathematician that has contributed significantly to Vedic mathematics is Brahmagupta. He was a classical Indian mathematician, not from the Vedic period, but what today is called as Vedic mathematics is a 20th century system popularized by Swami Bharati Krishna Tirtha ji. But even though these mathematicians who used to live way before Vedic mathematics, so they are not related to Vedic mathematics directly, but what we can say is Bharati Krishna Tirtha ji, when find and popularized the system of Vedic mathematics, he drew the inspiration from those methods that were already given by Indian mathematicians in the past, like Brahmagupta and Varamihira ji. So the important contributions of Brahmagupta ji are rules for zero, which is Sunya, which is popularly known by the name Sunya in Vedic mathematics. He gave contributions to development of positive and negative numbers. He gave the algebraic solutions of problems. He has significantly contributed to geometry and related topics, and he has contributed to the development of arithmetic progressions and series. Although Vedic mathematics is very modern, because it has been developed just 110 or 120 years before, but with the development of Vedic mathematics, Bharati Krishna Tirtha ji, who's popularly known as the founder of Vedic mathematics, he has drawn inspiration from these mathematicians from their works. That is why these mathematicians are somehow related to Vedic mathematics. So you see here, he draws inspiration from ancient Indian mathematical thinking, uses mental calculation, algebraic insight, and number sense, reflects Brahmagupta's emphasis on rules, patterns, and generalization. So Brahmagupta is best described as a pillar of Indian mathematics, whose work influenced that what later came to be presented as Vedic mathematics. So these ancient mathematicians have a very important role and a key role to play for the development to the development of Vedic mathematics. Next is Srinivas Ramanujan. As you all know about this mathematician, very famous. So his contributions to Vedic mathematics has been related to mental calculation and intuition, Indian mathematical tradition, myth making, and even though he is not directly related to Vedic mathematics, but his techniques and his methods and his contributions always have proven very beneficial for the development of this subject, which is Vedic mathematics. Now we have one more mathematician, Neelkant Somaiya. He has been very, why is he sometimes linked to Vedic mathematics? Because of his Sanskrit mathematical texts, Indian intellectual tradition that he has developed, and popular use of Vedic to mean ancient Indian. So he was one of the founders of early calculus. So calculus techniques are used for to calculate things in Vedic mathematics, and he has contributed significantly in trigonometry in the previous centuries. So these are the mathematicians who have contributed in their ways, in their own ways, and Bharati Krishna Tirtha ji later make use of those. He made use of those contributions and those teachings to develop for the development of Vedic mathematics. So that is why these mathematicians are related to Vedic mathematics. Now we have a very important contribution from Bharati Krishna Tirtha ji, who is believed to be the founder of Vedic mathematics. He was born in 1884 and he has contributed and published one book, namely Vedic Mathematics, in the year 1965. But that book was published posthumously after his death. So he has contributed majorly in this subject and he is known to be the father of Vedic mathematics. He has given the formulation of Vedic mathematics. He has given all 16 sutras and 13 sub-sutras that he has collected and recollected from different Vedas, and then he constituted the baseline of Vedic mathematics by using those 16 sutras and 13 sub-sutras, and then he simplifies the systems using these sutras like addition and subtraction. He has contributed in multiplication. He has made the problems of division easier. He has contributed in squaring and cubing and algebraic operations. So he has proposed different sutras to calculate addition, subtraction, multiplication, division, to find the square root of numbers or to find the cube root of numbers. So for these techniques where the mental abilities, he has given some more, I can say, very much contribution in this field. And by using these sutras, we can reduce that computational work and we can make our mental ability very strong. Another one is Baudhyana. As you can see, he has also contributed significantly to the development of Vedic mathematics. His major contributions in mathematics are statement of the Pythagorean theorem, geometrical constructions, approximation of under root 2, arithmetic and measurement, one of the earliest geometers in the world he is recognized to be, foundations of geometry in India, demonstrates practical mathematical thinking in Vedic rituals. That is why Bharati Krishna Tirtha ji has taken inspiration from him and taken a part of his contributions for the development of this subject. And then we have another one, Leelavati, which is a book on arithmetic. It is not in any sort of person, but a book in arithmetic which is written in Sanskrit, and we have a large part of things given in this subject in this book, which is based on systematic arithmetic, practical problem solving, world problems in verse, geometry. So Bharati Krishna Tirtha ji made the use of these contributions to develop Vedic mathematics and to make Vedic mathematics more people oriented, and so that people can use these techniques to calculate the squares, cube roots, addition and subtraction of different numbers. With this, today we complete the lecture, and I thank you all. Thank you very much.